Welcome back, my dear friends and dear students. A very good morning, good afternoon, good evening to all of you. And as you know, this is the DADM2 lecture series under NPTEL MOOC, which is DADM is basically means data analysis and decision making 2. And this course whole duration is for 12 weeks, which is 60 lectures, that is 30 hours. And each week we have 5 lectures, each being for half an hour. And if you can see in the slide, this is the 29th lecture, that means we are in the 6th week. So, with this 29th and 30th, we would wrap up the 6th week. And if we remember, we had just in the first 3 lectures, we have in this 6th week, we have been discussing about the ELECTRE method. And then after discussing the concept of ELECTRE, we did the small problem of the ELECTRE method, where the ranking, concordance and discordant concept were considered. And then in the last few minutes, or about last 5-6 minutes in the last lecture, which was the 28th one, I started the epsilon ELECTRE, where in the concept of epsilon we are now stating that any decision basically would have 3 different sets. One is the concordance, which is the liking one, discordance is the disliking one, and one is the indifference one, where I am still not decided that what should be the decision between A, K and A, L alternatives, considering the criteria. Now, remember one thing I did mention there, that in the utility functions we had considered the quadratic utility function, which was equally penalized. Then I went in the concept of Linux loss function, linear exponential loss function, where I showed and where I discussed those 3 examples, the civil engineering, electrical engineering and the marketing one. And I also did mention that you can basically have an area where you are indifferent depending on overestimation, underestimation of, or more liking, less liking. And based on that, we have the epsilon ELECTRE method. And remember, in the epsilon ELECTRE method, the epsilon value which you are going to take will depend on what is your risk averseness property. Now, this has something to do with, if you remember the AHP method, we had considered the principal diagonal to be 1 and the off diagonal element were asymmetric, but the scores were like 7, 1/7, 9, 1/9, 3, 1/3. So, the level of liking, disliking was basically based on the fact that what is the score I am going to give to the positive one and what is the inverse score I will give to the negative one. Negative one, that means I am forced to take that decision under the AHP method. Similarly, we did that for the ELECTRE method, and now we will continue extending that they may be a small bandwidth or a small set of values where I am indifferent between taking either AK or AL. Whether I take AK, and then when I consider it with respect to AL, K and L are the suffix which I am utilizing for the alternatives, and J are the different type of criteria. So, J changes from 1 to N, and KL, which is I, changes from 1 to M. M is in Mangalore. So, given the weights is basically what is the priority I am going to put to the different scores. I already have the values of y, which is coming from the scores which, or the utilities values which are assigned to decisions or alternatives for the criteria. And if you remember, they were converted using the logarithmic utility function with base of 10. That was just a simplistic assumption, it could have been done for base e also, Neperian log. And then we considered that the normalization would be done based on the fact that that actual cell value divided by the sum of all either the rows or the columns. So, this normalization would give you what is the overall utility concept you are trying to use. But remember, as I said, once you decide on the utility, stick to the utility function for that particular decision maker throughout the different stages of decision making, point 1. And point number 2 is that we will also consider the decision maker's utility for any group decision. If you remember, in the AHP method, we considered that buying either the car or trying to basically consider buying the house, or say for example, Ram and Shyam and their father and mother, that their parents giving their feedback. it would be considered that the utility function would stay throughout the set of decision makers as same, even though it may not be true. Practically, obviously, that will not be true. So, based on that, I also mentioned whether you normalize along the row or on the column, it would not change, but the answer, but the ranking, respective ranking. But remember that once you follow normalizing along the row or along the column, stick to that. So, as is the norm, we multiply each of the columns of the previous matrix X, which has been normalized. If you remember, the values were given, then logarithmic utility function we utilize, then we normalize. So, that is X. So, X is multiplied by the associate weights of the importance corresponding to the decision criteria. So, if the weights are given as W 1 to W n, remember the sum of the weight should be 1. Then we have y is equal to the matrix being the multiplication of X matrix multiplied by y and W is a vector here, we will convert it into a matrix. So, y will be given values, the cell of the y's would be given by x 1 multiplied by y 1, similarly the second values and so on and so forth. So, once we have that, we will proceed and find out the values. Just 1 minute, I think I should have calculated accordingly. So, these values are not 0, my apologies, I think these are. So, because if I am multiplying, just give me 1 minute, if I am multiplying the first cell, it should be then, when I am multiplying the last values, it should be x 1 into W n. So, I will copy W n here. So, it will be x 1 m. My apologies, there was a typo error here. So, this value, so all the cells have values, they are not 0 as pointed out, and the next last one would be x W 1, because this is the last value. So, W 1 this multiplied by x m 1. So, these are the values, my mistake. So, this will be I will just mark it to make it more clear and remove any confusion. So, consider this value, I am using different color. So, this would be x 1 multiplied by W 1, then the next value would be plus x 2 into 0, and all the values till the last one, which is x 1 n would be multiplied by 0. So, the value becomes x 1 W 1. This is the value which I have. So, this red color and red color match. Now, I go to green color. So, if I multiply, so this is this multiplied by the last one. So, this would be x 1 multiplied by 0 plus x 2 multiplied by 0 plus dot plus x 1 n multiplied by W n is equal to x 1 n W n. So, this value matches with the circled one. So, it matches. Similarly, if I take the color orange, this one would match when I multiply x m 1 multiplied by, so I should remove this. Multiplied by W 1, then it will be x m 2 multiplied by 0 plus dot plus x m n multiplied by 0. So, the final value becomes x m 1 multiplied by W1. So, this matches the colored yellow. Similarly, finally, if I do it for the last one, it will match. I am not writing it, or let me write it, it will be easy for all of you to understand. So, this will be x m1 multiplied by 0 plus x m2 multiplied by 0 plus dot 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 plus x mn into Wn. So, this is x mn Wn, this matches. So, it balances. So, the blue one matches this, the orange one matches this, the red one matches this, and the green one matches this. So, all these things are solved. So, once we have this, I consider a matrix of weights of 1/3, 1/3, 1/3. So, this is a very simplistic assumption, let me highlight it. So, these values of 1/3, 1/3, 1/3 I am taking in order to make R lifestyle, nothing else. So, once you have that, you multiply. So, if you remember, these are the normalized values, either the row or the column for the logarithmic of the utility function of the values, and then normalizing by the sum of the logs. Multiplied by 1/3 gives you these values. So, this is the values based on which we will work now. So, remember, before I proceed, I will request all the students or all the participants who are hearing these lectures, please write these values. So, the first value is 0.1033, I am calling along the row, first row, then 0.1233, then 0.1100, second value, second rows are 0.1200, next value is 0.0933, third value is 0.1133, third row is first value is 0.1133, second value is 0.1167, and the last value is 0.1100. So, please write these this matrix, which is y multiplication of x into w, and based on this we will do the calculation. Now, in epsilon ELECTRE method, I told you that we will basically have 3 different sets based on the indices. One will be the concordance indices, which will give us the concordance set, which is capital C. Then we will have the indifference indices will give us the indifference set or the matrix, which is capital I. And finally, we will have the discordant indices, which will give us the discordant matrix, which is capital D. So, our main task would be to find out capital C, capital I, and capital D. Now, let us go one by one what we mean by concordance indices values or index values, indifference index values, and discordant index values. That means liking, indifferent, and disliking. Concordance index is defined as the amount of evidence to support the conclusion that the alternative A k outranks or dominates alternative A L with respect to, say, for example, any of the criteria, which is basically j changing from 1 to n. So, we will compare A k with respect to A L for each of these j's. Similarly, discordance index is the counterpart of it opposite. If you remember, in general ELECTRE process, we had a concordance index and a discordant index. So, a discordant index is the counterpart of it in the sense that A k never outranks or dominates alternative A L. On the contrary, it is negative. Negative utility or negative value accrues to taking A k with respect to A L. So, that is the discordance index based on which we will have the discordance matrix capital D. Similarly, the last one, the indifference set or the indifference index would be when we compare A k and A L, and the comparison is such that one cannot rank them as per the utility one obtains with respect to one criteria which you have. So, for criteria j, if we compare A k and A L, we are indifferent. So, that will basically have and indifferent index value, and that value would be utilized to formulate the capital I, which is the indifference matrix. Now, here is basically where things becomes more interesting. So, when you are trying to formulate the concordance set, discordance set and the indifference set, if you consider very simply, you will basically have the straight line or the real line where we will have the scoring. Now, consider that if it was a general ELECTRE method, either you will take a value, anything value more, that means, if I am considering the real line from my side, anything positive on to the right, more towards positive would basically go into the concordance set, and anything basically on to the left would basically go into the discordance set. That means, we are dividing the whole set into two disjoint sets such that union of that is the universal set. So, they are mutually exclusive and exhaustive, two sets. Now, in this epsilon ELECTRE, we basically proceed further and divide the whole real line into three different zones or three different sets. So, say for example, the middle portion will be the indifferent set or indifferent indices, interest values. What is that zone or length of the zone, we do not know, that will be basically dictated by the utility function the human being or the decision maker has. On to the right, so of that zone, if I am looking from my side, on to the right more towards positive would be the concordance set, concordance index, concordance matrix. Any value on to the left of the indifferent zone would basically the discordant set or the discordant index and the discordant matrix. So, now we will need to formulate the rule that how do we get, when we compare AK with AL based on each and every criteria, what decision rule should we apply such that we can put the comparison of AK and AL in either the concordance set or the discordant set or in the indifferent set, that is all. Now, here we will add another a second level of intuitive feel or actually what is true. So, the indifference set would basically be made accordingly, which I will mention, but I would not go into solving that, only mention as we solve the problem, then general problem, and then basically talk about its variance. So, the concordant set or the concordant values CKL, when we are comparing K and L, it will basically for any J is basically the criteria, where we will basically have the difference of YK, that is that cell value which is there for YKL would be greater than YLJ plus some epsilon value depending on the liking disliking proposition which we have between K and L. So, where we will basically check as J changes from 1 to n, we will find out that how the large the difference of YK is there with respect to YKL with respect to YLJ, based on the fact that is epsilon j, which will give us some non-zero difference between the values of YKL and YL. Larger it is better, smaller it is not that good. So, these epsilon j's being can be different for different j's. So, say for example, for criteria 1 epsilon j is 0.01. For criteria 2 the epsilon value epsilon 2 can be say for example 0.002. Similarly, for epsilon 3, for j is equal to 3, the epsilon value can be 10 to the power minus 4, depending on however you basically formulate the problem, liking and disliking. So, this values of epsilon will imply that alternative AK outranks or dominates alternative J for each of the criteria differently, as I mentioned. So, if you remember the number line, so this is what is going to come. So, the whole number line I have not colored it, I will come to that coloring later on. The whole number line or the ranking set is such that we, as I mentioned, we divide into 3 zones. I am drawing it here, but technically it is much for an explanation. Actually, we would not formulate it when we solve the problem. So, generally we should have a region which is not liking. If I consider red as say for example, definitely not liked, if I consider orange as indifferent, like in the street lights what we have the red, the yellow and the green, and the green one being for the case when we basically have a liking. So, actually this should be red, yellow and green, but I am using the blue color in order to mention that. So, again note discordance red, indifference being yellow, and definitely I like concordance being green. But I am using the blue color to give the notation that the concordance set is there. So, the blue line depicts the region where YKL is greater than YLJ. So, which is plus some epsilon j depending on j the criteria, and it will hold such that one would get a positive benefit of some amount plus something given for alternative, given that alternative A k is taken with respect to A L for A j is equal to 1 to n, where n are the criteria. The black line now on to the left is basically like the combination of the discordance and the indifference set. So, basically it says the black line denotes the union, this is what was important. It basically gives the union and indifference and discordance sets of the criteria for the comparison between A k and A L for any of the j criteria. Now, let us come to the indifference set. So, indifference set, if you remember, I have marked it at the yellow one in between. Now, that difference can be asymmetric depending on what level of asymmetricity you want. That means, like indifference can also be out of different values. So, in the indifference set I k l will, when we compare A k with A L for those j's values, if the mod of the difference are less than some epsilon value. So, epsilon again j means 1 to n would keep changing depending on the criteria, and epsilon j as I said. So, it will imply that A k is indifferent with respect to A L within a bandwidth of A k L minus A j L, or that means y I would not be using that A, y k L minus y L j is that mod value is less than equal to epsilon indifferent to alternatives A L for each criteria within a certain range, and that range would be dictated by the criteria. It can also be dictated by a different levels of epsilon, like say for example, for the value of criteria j 3, we can have a positive and a negative one. So, one epsilon value for the indifference being in the positive side and in the negative side. That means, we have the bandwidth of indifference. That indifference can also be divided into two unequal zones. That unequal zones would basically be dictated by the epsilon 3 1 and epsilon 3 2. 3 number 3 is basically for the criteria, and 1 and 2 are the different levels of epsilon we assign. So, that yellow region now is that this one which we have divided unequally. It need not be unequal, it can be equal also. So, we basically formulate the rule epsilon j 1 and j 2, which I said epsilon 3 1 and 3 2. So, the blue line which is in between. So, if I remove it, it will be, you will be able to see. The blue line depicts the region where the difference is either less than equal to epsilon j 1 or less than equal to epsilon j 2 depending on which side you are looking for, and it will hold true that such that one would get a positive benefit by taking A k with respect to A L depending on epsilon values and the criteria number. The black portion of the line denotes the union now on the left and the right. So, if I go, this is the discordant value and this is the concordance value. So, the black line is basically the union of red and green. Now, let us come into the discordance set. So, the discordance set would be for those j values where y k L is less than equal to y L j minus epsilon value. So, higher or lower the epsilon value corresponding to that j would dictate what is the level of discordance and to what level. So, here also we have this I have marked red, actually as should be. So, this is the discordant region which we have, and technically this is basically the indifference region. So, and this is basically the concordance and liking region. So, again the universal set of the whole points is divided into 3 zones. So, you will basically have the discordance at D. Now, concordance will be denoted by C with the corresponding suffix, indifference will be denoted by I with the corresponding suffix, and discordant sets or indices will be denoted by D with the corresponding suffix. So, D values for each and every j would be calculated, where epsilon j being different for different j's, which implies the alternative A k does not benefit or is worse off by taking that alternative A k and not A l. So, here the red line depicts the region where y k l is less than y l j minus that epsilon j depending on the value of epsilon j. So, such that one would get a negative benefit or a disbenefit by taking A l with respect to A k with respect to A l, my apologies, based on the criteria number, because epsilon j would dictate the level of discordance concept. The black portion again would basically denote the union of the concordance and the discordance set. So, concordance, this is the values in indifferent and this is the value for the concordance. So, we have this black line. I should have drawn, but I have omitted it. Now, these values, the y values were already calculated using the normalized utility values which had been there, multiplied by the w values which is the weights, and this matrix y was given. Now, we will just follow the rule given and calculate the values, and I will only talk about the values end results rather than going into the detailed calculations. So, we will first find out C11, D11 and I11 with concordance, discordance and indifferent. Initially for the ELECTRE method it was only C and D. For j is equal to 1, we formulate and find out the difference, and we are considering epsilon equal to 0.01, it can be anything else also, and I am considering, remember this epsilon j I am considering same for whatever j it is there, j 1, 2, 3 does not change the values of epsilon, even though I had mentioned that in the last few minutes, but I am considering that 0.01. Based on j is equal to 1, we find out that for the first criteria it belongs to indifferent one, for the second one it belongs to indifferent one, third one it belongs to an indifferent one. That should basically be so, because we are comparing the values of 1 to 1. So, that means I am comparing alternative 1 to 1. So, once we have this, I will just highlight C11 is a null set, D11 is a null set, indifference are 1 to 3. Initially in the epsilon method, these 1 to 3 would have gone into the C set. When I consider C12, D12 and I12, and then I will consider D13, D13, D13 and I13. So, the values for j is equal to 1, 2 and 3 for C12, D12 and I12. Please calculate it considering the values of epsilon as fixed as 0.01. We have 1 belongs to the discordant set, 2 belongs to the concordant set, and 3 belongs to the indifferent set. Similarly, for C13, D13 and I13, to find out for j is equal to 1, 2, 3, again the same value in epsilon of 0.01, we find out, do this calculations, if you, it is very simple. Then the concordant set element is null, indifferent is basically 1, 2, 3 and discordant is null. So, we will proceed accordingly and then calculate and find out the values. With this I will end the 29th lecture for this DADM 2 and try to wrap up the epsilon ELECTRE in the last lecture for the 6th week. Have a nice day and thank you very much for your attention.